What if the universe itself is nothing more than a sophisticated simulation, and every star, every planet, even every thought you've ever had, is part of an elaborate program? Imagine for a moment that the reality you know, the ground beneath your feet, the air you breathe, the vast expanse of space, is all just lines of code running on some unimaginably advanced computer. This isn't science fiction. This is simulation theory, a mind-bending idea that suggests our entire existence might be an artificial construct. And what if the key to uncovering this truth lies not in our world, but in the strange, unexplained anomalies scattered across the cosmos? From mysterious signals echoing through the void to black holes that defy the laws of physics, these cosmic oddities might be the clues that reveal we're living in a simulation. In this video, we're diving deep into the mysteries of the universe to explore the space anomalies that could prove we're not real. Stay with us, because by the end, you might just question everything you thought you knew about reality itself. Now, let's take a step back and explore the foundations of simulation theory. This idea isn't as new as it might seem. In fact, its roots stretch all the way back to ancient philosophy. Thinkers like Plato pondered the nature of reality, suggesting that what we perceive might not be the true form of existence. Fast forward to the modern era, and the concept has evolved dramatically, thanks to thinkers like Nick Bostrom. In 2003, Bostrom proposed a groundbreaking argument that it's highly probable we're living in a simulation created by a civilization far more advanced than our own. At its core, simulation theory suggests that our reality, everything we see, touch, and experience, might be an artificial construct, a kind of ultra-sophisticated computer program. This isn't just a wild guess. Bostrom's trilemma presents three possibilities. Either advanced civilizations go extinct before they can create simulations, they choose not to create them, or we are almost certainly living in one. The implications are staggering. If even one advanced civilization survives long enough to develop the technology to simulate entire universes, the odds tilt heavily in favor of us being part of that simulation. So, as we dive deeper into the mysteries of the cosmos, keep this in mind. The anomalies we're about to explore might not just be quirks of nature, they could be the fingerprints of a simulated reality. Now, let's shift our focus to one of the most puzzling questions in the cosmos, the Fermi Paradox. Named after physicist Enrico Fermi, this paradox highlights a striking contradiction. Given the vastness of the universe and the high probability of extraterrestrial life, why haven't we found any evidence of it? Where is everyone? This question becomes even more intriguing when we consider it through the lens of simulation theory. If our reality is a simulation, the absence of alien civilizations might not be a mystery. It could be a deliberate design choice. Think about it. If an advanced civilization created this simulation, they might have programmed it to isolate us, ensuring we don't encounter other intelligent life forms. This isolation could serve a purpose, whether it's to study us in a controlled environment or to prevent us from discovering the truth about our simulated existence. Alternatively, the lack of contact with extraterrestrials might be a glitch in the simulation itself, a limitation of the program's capacity to render complex alien civilizations. Either way, the Fermi Paradox raises fascinating questions about the nature of our reality. Could the eerie silence of the universe be a clue that we're living in a simulation? As we continue to explore the cosmos, this paradox reminds us that the answers we seek might be closer and stranger than we ever imagined. Now, let's turn our attention to something equally mind-bending: space anomalies. These are the cosmic oddities that defy our current understanding of the universe. From unexplained gravitational waves to mysterious signals echoing across the void, space anomalies are the universe's way of keeping us on our toes. But what exactly are they? In simple terms, space anomalies are phenomena that don't fit neatly into our scientific models. They're the outliers, the cosmic glitches that make us question everything we think we know. Take, for example, fast radio bursts, those brief, intense flashes of energy that come from deep space. We don't know what causes them, but they're so powerful that they can outshine entire galaxies for a fraction of a second. Then there are gravitational anomalies, like the strange behavior of stars orbiting the center of our galaxy, which move in ways that suggest the presence of something massive and invisible, possibly dark matter. And let's not forget the WOW signal, a mysterious radio signal detected in 1977 that has never been explained. These anomalies aren't just scientific curiosities, they're clues. They challenge our understanding of reality, forcing us to rethink the rules of physics and the nature of the cosmos. Could these anomalies be evidence of a simulated universe? If our reality is a program, these unexplained phenomena might be glitches in the code, hints that something isn't quite right. Or perhaps they're deliberate features designed to test our curiosity and push us toward discovery. Either way, space anomalies remind us that the universe is far stranger and more mysterious than we can imagine. And as we continue to explore, they might just hold the key to unlocking the truth about our existence. Now, let's shift our focus to one of the most fascinating experiments in quantum physics, the double-slit experiment. This groundbreaking study reveals something truly bizarre about the nature of reality. When particles, like electrons or photons, are fired at a barrier with two slits, they don't behave as you'd expect. Instead of simply passing through one slit or the other, they create an interference pattern on the other side, as if they're behaving like waves. But here's where it gets even stranger. When scientists try to observe which slit the particle goes through, the interference pattern disappears. The particles suddenly start behaving like particles again, as if they're aware they're being watched. This phenomenon has puzzled physicists for decades. It suggests that the act of observation itself changes the behavior of particles. But what does this mean for our understanding of reality? Some theorists argue that this could be evidence of a simulated universe. If our reality is a program, it might only render what's being observed to save computational resources. Think of it like a video game. The game doesn't render every detail of the entire world at once. Instead, it only loads what's in the player's field of view. Similarly, in a simulated reality, the universe might only render the parts we're actively observing. This would explain why particles behave differently when we're not looking, because the simulation doesn't need to fully compute their behavior until we observe them. The double-slit experiment challenges our most basic assumptions about reality, suggesting that the universe might not be as solid and objective as it seems. Could this be a clue that we're living in a simulation? It's a question that continues to spark debate and curiosity, pushing us to rethink the very fabric of existence. And as we explore further, experiments like this might just hold the key to unlocking the true nature of our reality. Now, let's take a step further into the quantum realm and explore another mind-bending phenomenon: quantum entanglement. Imagine two particles separated by vast distances, perhaps even light years apart, yet somehow they remain deeply connected. When one particle's state changes, the other instantly responds, no matter how far apart they are. Albert Einstein famously called this spooky action at a distance, and for good reason. It defies our everyday understanding of how the universe should work. How can two particles communicate faster than the speed of light, seemingly breaking the rules of physics? This strange behavior has led some scientists to wonder if quantum entanglement could be evidence of a simulated universe. Think about it. In a computer program, objects don't need to follow the same physical laws we experience in the real world. Instead, they can be linked through code, allowing them to interact instantaneously, no matter how far apart they are. If our reality is a simulation, quantum entanglement might be a kind of programmed shortcut, a way for the system to bypass the usual constraints of space and time. This idea becomes even more intriguing when we consider how simulations work. In a video game, for example, two characters might appear to interact in real time, even though their connection is managed by the game's underlying code. Similarly, entangled particles could be programmed to mirror each other's states, creating the illusion of instantaneous communication. This would explain why entanglement seems to defy the laws of physics because it's not bound by them. Instead, it's a feature of the simulation designed to optimize the system's performance. Quantum entanglement challenges our understanding of reality in profound ways. It suggests that the universe might not operate on the principles we once thought were fundamental. Instead, it could be governed by a set of rules that only make sense if we're living in a simulated environment. As we continue to unravel the mysteries of quantum physics, phenomena like entanglement might provide the clues we need to answer one of the biggest questions of all. Are we living in a simulation? The implications are staggering, and the journey to uncover the truth is just beginning. Next, we'll dive into another fascinating concept that aligns with simulation theory, the holographic principle. Could our universe be a projection, a hologram encoded on a two-dimensional surface? Let's find out. Now, let's shift our focus to an idea that sounds like it's straight out of science fiction, but has serious scientific backing: the holographic principle. This concept suggests that our universe, with all its three-dimensional complexity, might actually be a projection, a hologram encoded on a two-dimensional surface. At first glance, this seems impossible. How could everything we see, touch, and experience be reduced to a flat, two-dimensional plane? Yet this idea has gained traction among physicists and aligns eerily well with simulation theory. The holographic principle emerged from the study of black holes. Scientists discovered that all the information about matter falling into a black hole isn't lost, but is instead encoded on its event horizon, the boundary surrounding the black hole. This realization led to the idea that the universe itself might work in a similar way. Just as a hologram creates the illusion of depth from a flat surface, our reality could be a projection of information stored on a two-dimensional boundary at the edge of the cosmos. Think of it like this. Imagine watching a movie on a screen. The images appear three-dimensional, with depth and movement, but they're actually just flat pixels arranged in a specific way. In the same way, our universe might be a kind of cosmic movie, with all the information about space, time, and matter encoded on a two-dimensional surface. This would mean that what we perceive as reality is just a highly detailed projection, a rendered image created by the underlying code of the simulation. This idea ties directly into simulation theory. If our universe is a simulation, it would need a way to store and process vast amounts of information efficiently. Encoding everything on a two-dimensional surface would be a clever way to save computational resources. Instead of rendering every detail in 3 dimensions, the simulation could project the illusion of depth from a simpler, 2-dimensional framework. This would explain why the universe appears so complex and detailed, because it's being generated by an incredibly sophisticated system. The holographic principle also raises fascinating questions about the nature of reality. If everything we experience is just a projection, what does that mean for our sense of self? Are we, too, just part of the hologram? And if so, who or what is projecting it? These questions push us to rethink not just the physical laws of the universe, but also the very nature of existence. As we explore these ideas, it's worth noting that the holographic principle isn't just a wild speculation. It's supported by mathematical models and has been the subject of serious scientific research. While it's still a theory, it offers a compelling framework for understanding how a simulated universe might operate. And if it's true, it could be one of the most profound discoveries in human history, revealing that reality, as we know, it is far stranger than we ever imagined. Next, we'll delve into another cosmic mystery that could further support the idea of a simulated universe: black holes and the information paradox. What happens to information that falls into a black hole, and could this be a glitch in the simulation? Let's find out. Now, let's turn our attention to one of the most perplexing mysteries in the cosmos: black holes and the information paradox. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. But here's where things get strange. According to the laws of quantum mechanics, information about the state of matter can never be destroyed. Yet, when matter falls into a black hole, it seems to vanish completely, leaving no trace. This contradiction is known as the information paradox, and it has puzzled scientists for decades. So, what happens to the information that falls into a black hole? One possibility is that it's not truly lost, but somehow encoded on the black hole's event horizon, the boundary beyond which nothing can escape. This idea ties back to the holographic principle we discussed earlier. Just as the universe might be a projection of information stored on a 2-dimensional surface, the information swallowed by a black hole could be preserved on its event horizon. But if that's the case, how does it escape? And what does this mean for the nature of reality? This is where simulation theory comes into play. If our universe is a simulation, the information paradox could be a clue, a glitch in the system. In a simulated reality, information might not need to follow the same rules as in a physical universe. Instead, it could be processed or stored in ways that defy our current understanding of physics. For example, the simulation might recycle information or compress it in ways that make it seem lost to us, but are actually part of the program's design. Think of it like a computer game. When you delete a file, it's not truly gone, it's just marked as available space for new data. Similarly, the information that falls into a black hole might not be destroyed, but instead repurposed or hidden within the simulation's code. This would explain why it appears to vanish while still adhering to the rules of the program running our reality. The information paradox also raises questions about the limits of our understanding. If black holes can delete information, does that mean the simulation has a way of managing data that we can't comprehend? Or could it be a deliberate feature designed to keep us from uncovering the true nature of the simulation? These questions challenge us to rethink not just black holes, but the very fabric of reality itself. As we continue to explore these ideas, it's worth noting that the information paradox isn't just a theoretical puzzle. It's a real scientific problem that has sparked intense debate and research. some physicists believe that solving this paradox could lead to a deeper understanding of the universe, or even reveal that we're living in a simulation. Whether or not that's the case, the mysteries of black holes remind us that reality is far stranger than we often assume. Next, we'll dive into another cosmic enigma that could further support the idea of a simulated universe: dark matter and dark energy. What are these mysterious forces, and could they be part of the code running the simulation? Let's find out. Now, let's shift our focus to another cosmic mystery that could hold the key to understanding whether we're living in a simulation: dark matter and dark energy. Together, these two invisible forces make up about 95% of the universe, yet we know almost nothing about them. Dark matter is the unseen substance that holds galaxies together, while dark energy is the mysterious force driving the universe's accelerated expansion. But what if these forces aren't just natural phenomena? What if they're part of the code that runs our simulated reality? To understand why this idea isn't as far-fetched as it sounds, let's break it down. Dark matter, for instance, doesn't interact with light or any other form of electromagnetic radiation, which is why we can't see it. We only know it exists because of its gravitational effects on visible matter, like stars and galaxies. But here's the twist. In a simulated universe, dark matter could simply be a placeholder, a way for the program to account for the gravitational forces needed to keep the simulation running smoothly. Think of it as the invisible scaffolding that holds the digital world together. Dark energy, on the other hand, is even more puzzling. It's the force causing the universe to expand faster and faster, pushing galaxies apart at an accelerating rate. If our universe were a simulation, dark energy could be a built-in mechanism to ensure the program continues to run without collapsing. It might act like a background process, constantly adjusting the parameters to maintain the simulation's stability. In other words, dark energy could be the energy source powering the simulation, much like electricity powers a computer. This idea becomes even more intriguing when we consider how precise the values of dark matter and dark energy are. The universe seems to be fine-tuned in a way that allows galaxies, stars, and planets to form. If these values were even slightly different, life as we know it wouldn't exist. This fine-tuning has led some scientists to speculate that our universe might be designed or programmed with specific parameters in mind. Could dark matter and dark energy be part of that programming, ensuring the simulation runs as intended? Of course, this raises another question. If dark matter and dark energy are part of the simulation's code, what does that mean for us? Are we simply characters in a cosmic video game, unaware of the underlying rules that govern our existence? Or could understanding these forces help us uncover the true nature of reality? While we don't have definitive answers yet, the possibility that dark matter and dark energy are part of a simulated universe adds another layer of intrigue to these cosmic mysteries. As we continue to explore the universe, one thing is clear: the more we learn, the more questions we uncover. Dark matter and dark energy remind us that there's still so much we don't understand about the cosmos, and that's what makes them so fascinating. Whether they're natural phenomena or part of a grand simulation, they challenge us to rethink everything we thought we knew about reality. Next, we'll examine another eerie aspect of the universe that could further support the idea of a simulation: the Great Silence. Why is the universe so quiet, and could this silence be a deliberate feature of the simulation? Let's explore this next. Now, let's turn our attention to one of the most haunting mysteries of the cosmos: the Great Silence. Despite the vastness of the universe, filled with billions of galaxies and trillions of stars, we've yet to detect any signs of intelligent extraterrestrial life. This eerie quiet has puzzled scientists for decades and has even been given a name, the Fermi Paradox. But what if this silence isn't just a coincidence? What if it's a deliberate feature of the simulation we might be living in? To understand why this idea is worth considering, let's first look at the numbers. The universe is unimaginably large, with countless planets that could potentially support life. Given the odds, it seems almost impossible that we're alone. Yet, despite decades of searching, we found no evidence of other civilizations. No signals, no artifacts, no signs of advanced technology. This absence of contact is what makes the Great Silence so unsettling. One possible explanation is that intelligent life is incredibly rare, and we just happen to be the first, or the only civilization to emerge. But another, more intriguing possibility is that the silence is by design. If our universe is a simulation, the lack of contact with extraterrestrial civilizations could be a deliberate choice by the programmers. Imagine a simulation designed to isolate its inhabitants, keeping them unaware of other intelligent beings to maintain control or to study them in a controlled environment. In this scenario, the Great Silence isn't an accident, it's a feature. This idea ties back to the Fermi Paradox in a fascinating way. If advanced civilizations exist, why haven't they made contact? One theory suggests that they might have self-destructed before reaching a stage where interstellar communication is possible. But another, more speculative theory is that they've been intentionally hidden from us. Perhaps the simulation's parameters are set to prevent us from encountering other civilizations, ensuring that we remain isolated and focused on our own development. Another angle to consider is the possibility that extraterrestrial civilizations are aware of the simulation and choose not to interfere. If they understand that our reality is artificial, they might avoid contact to preserve the integrity of the experiment. This would explain not only the lack of signals, but also the absence of any physical evidence of their existence. In this view, the Great Silence becomes a form of cosmic respect, a decision to let us evolve without external influence. Of course, there's also the chance that we're simply not looking in the right way. Our methods of searching for extraterrestrial life are still in their infancy, and it's possible that advanced civilizations communicate in ways we can't yet detect. But even if that's the case, the silence remains a profound mystery. Whether it's a natural phenomenon or a deliberate feature of a simulated reality, the Great Silence challenges us to rethink our place in the universe. As we ponder this cosmic quiet, one thing becomes clear: the absence of contact is as thought-provoking as the possibility of contact itself. Whether we're alone in the universe or part of a carefully orchestrated simulation, the Great Silence reminds us that there's still so much we don't understand. And that's what makes it such a compelling mystery. Next, we'll explore another fascinating piece of the puzzle: the precise mathematical constants that govern our universe. Could these finely tuned values be evidence of a designed simulation? Let's dive into this next. Now, let's shift our focus to something that might seem small but holds immense significance: the mathematical constants that govern our universe. These numbers, like the speed of light, the gravitational constant, and the charge of an electron, are so precise that even the slightest change would make life as we know it impossible. This phenomenon is often referred to as fine-tuning, and it raises a profound question: is this precision a result of random chance, or could it be evidence of a designed simulation? To understand why this is so fascinating, let's take a closer look at some of these constants. For example, the strength of gravity is just right to allow stars and planets to form. If it were even slightly stronger, stars would burn out too quickly, and if it were weaker, they might not form at all. Similarly, the cosmological constant, which determines the rate of the universe's expansion, is so finely balanced that if it were off by even a tiny fraction, the universe would either collapse in on itself or expand too rapidly for galaxies to form. These aren't just coincidences, they're precise values that seem to be perfectly calibrated for life to exist. This level of precision has led some scientists and philosophers to wonder if it's more than just luck. Could these constants be the result of a deliberate design? If our universe is a simulation, it's possible that these values were carefully chosen by the programmers to create a stable and functional environment. In this view, the fine-tuning of the universe isn't an accident, it's a feature of the simulation, designed to allow complex structures like stars, planets, and life to emerge. But not everyone agrees with this interpretation. Some argue that the fine-tuning of the universe could be explained by the multiverse theory. According to this idea, there are countless universes, each with different constants and physical laws. In most of these universes, the conditions are too extreme for life to exist, but in a few, like ours, the constants happen to be just right. From this perspective, our universe isn't special, it's just one of many, and we happen to be in the one where life is possible. However, even the multiverse theory doesn't fully resolve the mystery. If there are infinite universes, why do the constants in ours seem so perfectly balanced? Could it still be a sign of design, even within a multiverse framework? These questions push us to consider whether the fine-tuning of the universe is evidence of a deeper, more intentional structure, one that might point to a simulated reality. As we explore these ideas, it's worth noting that the debate over fine-tuning isn't just about science, it's also about philosophy. It challenges us to think about the nature of existence and whether the universe is the product of chance or design. Whether you believe in a multiverse, a simulation, or something else entirely, the fine-tuning of the universe is a reminder of how much we still have to learn about the cosmos. Next, we'll delve into another intriguing aspect of this mystery, the so-called glitches in the matrix. Could strange phenomena like déjà vu or the Mandela effect be evidence of errors in a simulated reality? Let's explore this fascinating possibility. Now, let's turn our attention to something that feels almost like science fiction, but might be closer to reality than we think: glitches in the matrix. These are moments when the world around us seems to behave in ways that defy explanation, leaving us questioning the very fabric of our reality. From déjà vu to the Mandela effect, these strange occurrences have sparked debates about whether they could be evidence of errors in a simulated universe. Déjà vu, for instance, is that eerie feeling of having already experienced something that's happening for the first time. It's a phenomenon that most of us have encountered at some point. But what if it's more than just a trick of the mind? Some theorists suggest that déjà vu could be a glitch in the simulation, a momentary overlap or repetition in the code that creates the illusion of familiarity. Imagine the universe as a vast computer program. If there's a hiccup in the system, it might briefly replay a sequence, making us feel like we've been there before. Then there's the Mandela effect, a term coined to describe collective false memories shared by large groups of people. For example, many people vividly remember Nelson Mandela dying in prison in the 1980s, even though he was released and lived until 2013. How can so many people recall the same incorrect event? Could this be a sign that the simulation has been altered or updated, leaving traces of a previous version in our memories? It's a fascinating idea, suggesting that our reality might not be as fixed as we think. Beyond these well-known examples, there are countless unexplained phenomena that could also point to potential glitches. Have you ever experienced a moment when time seemed to slow down or speed up for no apparent reason? Or perhaps you've encountered objects that appear to vanish and reappear in places you're certain they weren't before. These oddities might seem trivial, but in the context of simulation theory, they take on a whole new meaning. Could these be minor errors in the program, brief moments when the simulation reveals its true nature? Of course, skeptics argue that these phenomena can be explained by psychology or simple coincidences. Déjà vu, for instance, might just be a misfire in the brain's memory systems, while the Mandela effect could stem from the way misinformation spreads in the digital age. But even if these explanations hold some truth, they don't entirely rule out the possibility of a simulated reality. After all, if we're living in a simulation, wouldn't the programmers design it to mimic the quirks of human perception and memory? As we consider these ideas, it's worth reflecting on how they challenge our understanding of reality. If glitches like these are real, they could be subtle clues that the universe isn't as solid or predictable as it seems. They invite us to question not just the nature of our existence, but also the reliability of our own perceptions. Are these moments of strangeness mere anomalies, or are they glimpses behind the curtain of a simulated world? Next, we'll explore another mind-bending concept: time dilation and relativity. How do Einstein's theories about time and space fit into the idea of a simulated universe? Let's dive into this intriguing connection. Now, let's shift our focus to another fascinating piece of the puzzle: time dilation and relativity. Einstein's theory of relativity revolutionized our understanding of time and space, revealing that time isn't as constant as it seems. Near massive objects or at incredibly high speeds, time can actually slow down, a phenomenon known as time dilation. But what if this isn't just a quirk of physics? What if it's a feature of a simulated universe? Imagine the universe as a vast, intricate computer program. In such a simulation, rendering every detail in real time would require an enormous amount of computational power. To optimize performance, the programmers might implement shortcuts, like slowing down time in areas where extreme conditions exist. For instance, near a black hole, where gravity is immense, time dilation could be a way to reduce the processing load, ensuring the simulation runs smoothly without overloading the system. Similarly, at near light speeds, time slows down for the moving object, which could be another optimization trick to handle the complexity of high-speed interactions. This idea becomes even more intriguing when we consider how time dilation aligns with the concept of a simulated reality. If the universe is a simulation, then time itself might not be a fundamental aspect of existence, but rather a programmed variable. The fact that time can stretch and warp depending on conditions could suggest that it's a flexible, adjustable parameter within the simulation, rather than an immutable force. It's as if the code of the universe has built-in mechanisms to handle extreme scenarios, ensuring consistency and stability. Einstein's theories also introduce the idea that space and time are interwoven into a single fabric called space-time. In a simulated universe, this fabric could be the underlying framework that the simulation operates on. The bending of space-time around massive objects, like planets or black holes, might be a way for the simulation to manage gravitational effects efficiently. It's almost as if the universe has a set of rules like the laws of physics that govern how the simulation behaves, and time dilation is one of those rules. But here's where it gets even more mind-bending. If time is a programmed variable, then our perception of time might also be part of the simulation. Could our sense of time passing be an illusion, a way for the simulation to create a coherent experience for us? After all, in a simulated reality, everything we perceive, our memories, our sense of past and future, could be part of the program. This raises profound questions about the nature of existence and whether time, as we know it, is real or just another layer of the simulation. Of course, this is all speculative, but it's a compelling way to think about the mysteries of relativity and time dilation. Whether or not we're living in a simulation, these phenomena challenge our understanding of reality and invite us to consider the possibility that the universe operates in ways far beyond our current comprehension. Next, we'll explore another cornerstone of simulation theory, the simulation argument by Nick Bostrom. What does his trilemma tell us about the likelihood of living in a simulated reality? Let's dive in. Now, let's turn our attention to one of the most compelling arguments in favor of simulation theory, the simulation argument proposed by philosopher Nick Bostrom. At its core, Bostrom's argument presents a trilemma, a set of three possibilities, at least one of which must be true. The first possibility is that nearly all civilizations at our level of technological advancement go extinct before they can develop the capability to create realistic simulations of their ancestors. The second is that even if they reach that level of technology, they choose not to run such simulations. And the third is that we are almost certainly living in a simulation right now. Let's unpack this step by step. The first scenario suggests that the odds are stacked against civilizations surviving long enough to create ancestor simulations. This could be due to self-destruction, natural disasters, or other existential threats. If this is the case, then the likelihood of us being in a simulation is extremely low, because the technology required to create such simulations would never come to exist. The second possibility is that advanced civilizations do reach the technological capability to create simulations, but decide against it. Perhaps they consider it unethical, or maybe they simply have no interest in simulating their ancestors. If this is true, then again, the chances of us living in a simulation are slim. But it's the third possibility that really grabs our attention. If advanced civilizations do exist, and if they have both the capability and the desire to run simulations of their ancestors, then the number of simulated realities would vastly outnumber the one base reality. In other words, for every real civilization, there could be billions or even trillions of simulated ones. If that's the case, the odds of us being in the one true reality are astronomically low. Statistically speaking, it's far more likely that we're living in one of the countless simulations. Bostrom's argument doesn't claim that we are definitely in a simulation, but it does suggest that at least one of these three possibilities must be true. And if the first two are unlikely, if civilizations do survive and choose to run simulations, then the third becomes almost inevitable. This is why Bostrom's trilemma is such a powerful piece of the simulation theory puzzle. It forces us to confront the possibility that our reality might not be as fundamental as we think. What makes this argument even more intriguing is that it doesn't rely on any specific technological details or assumptions about the nature of consciousness. Instead, it's based on probability and logic, making it accessible even to those who aren't experts in physics or computer science. It's a thought experiment that challenges us to reconsider our place in the universe and the nature of existence itself. As we ponder Bostrom's trilemma, it's worth asking, if we are living in a simulation, what does that mean for our understanding of reality, morality, and even free will? These are questions that take us beyond the realm of science and into the domain of philosophy, where the implications of simulation theory become even more profound. Next, we'll explore another layer of this fascinating theory, the idea of simulated consciousness. What if our thoughts, memories, and sense of self are also part of the program? Let's dive deeper into this mind-bending concept. Now, let's take a step further into the mind-bending realm of simulation theory by examining the concept of simulated consciousness. What if not just the world around us, but our very thoughts, memories, and sense of self are part of the program? This idea pushes the boundaries of what it means to be real and challenges our understanding of identity and free will. Imagine for a moment that your consciousness, your thoughts, emotions, and perceptions are not the product of a biological brain, but rather lines of code in a vast simulation. If this were true, then every decision you make, every memory you hold, and every feeling you experience could be pre-programmed or influenced by the simulation's parameters. This raises profound questions about free will. If our choices are determined by the rules of the simulation, do we truly have the ability to make independent decisions? Or are we merely following a script written by the architects of this virtual reality? The implications for identity are equally staggering. If our consciousness is simulated, then the self we perceive, the person we believe ourselves to be, might not exist in the way we think. Our sense of individuality, our memories, even our personalities could be constructs of the simulation. This challenges the very foundation of how we define who we are. Are we unique beings with free will, or are we characters in an elaborate digital narrative? Some philosophers and scientists argue that if consciousness can be simulated, it might be indistinguishable from real consciousness. In other words, if a simulated mind can think, feel, and perceive just as a biological mind does it matter whether it's made of neurons or code? This idea blurs the line between reality and illusion, forcing us to reconsider what it means to be conscious at all. But let's not stop there. If our consciousness is part of the simulation, what does that mean for the nature of existence? Could the simulation be designed to test certain scenarios, like a cosmic experiment? Or perhaps it's a form of entertainment for a higher intelligence, watching our lives unfold like episodes of a grand, interactive show. These possibilities, while speculative, open up a world of philosophical and existential questions that challenge our most fundamental beliefs. As we grapple with these ideas, it's worth considering how they might change our perspective on life. If our reality is a simulation, does that make our experiences any less meaningful? Or does it add a layer of complexity to the way we understand purpose and existence? These are questions that don't have easy answers, but they invite us to think deeply about the nature of reality and our place within it. With these thoughts in mind, let's shift our focus to another intriguing aspect of simulation theory, the concept of parallel universes and multiverse theory. Could there be multiple simulations running simultaneously, each with its own version of reality? Let's explore this fascinating idea next. Now, let's venture into the fascinating realm of parallel universes and multiverse theory, and how they might intertwine with the idea of a simulated reality. If our universe is indeed a simulation, could there be countless other simulations running alongside it? each representing a different version of reality. This concept takes the mind-bending possibilities of simulation theory to an entirely new level. Imagine a vast network of simulations, each one a unique instance of reality, where every possible outcome of every decision plays out in its own universe. In this framework, the multiverse isn't just a collection of alternate realities. It could be a series of separate simulations, each programmed with its own set of rules, constants, and initial conditions. This raises the question: if our universe is one of many simulations, what distinguishes it from the others? Are we in the main simulation, or are we just one of countless experiments running in the background? The idea of parallel universes isn't just science fiction. It's a serious topic in theoretical physics. The multiverse theory suggests that every time a decision is made, the universe splits into multiple branches, creating alternate timelines where different outcomes occur. If we apply this to simulation theory, each of these branches could be a separate simulation, running simultaneously but independently. This would mean that every possible version of you exists somewhere in the multiverse, living out every conceivable choice and consequence. But here's where it gets even more intriguing. If each universe is a separate simulation, could there be communication or interaction between them? Some theories propose that certain anomalies in our universe, like unexplained cosmic signals or quantum entanglement, might be evidence of crosstalk between simulations. Could these be glitches or intentional connections designed by the architects of the simulation? The possibility opens up a whole new layer of mystery about the nature of our reality. Another angle to consider is the purpose behind such a multiverse of simulations. If a higher intelligence or advanced civilization is running these simulations, why create so many? Are they testing different scenarios, exploring every possible outcome of a given situation? Or could it be a form of entertainment, with each simulation offering a unique narrative for its creators to observe? These questions push us to think beyond our own existence and consider the motivations of those who might have designed the simulation. As we ponder these ideas, it's worth reflecting on how they might change our perspective on life and the choices we make. If every decision spawns a new simulation, does that make our actions more or less significant? On one hand, it suggests that every choice matters as it creates a new reality. On the other hand, it could imply that our decisions are just one of countless possibilities, each playing out in its own isolated simulation. This exploration of parallel universes and multiverse theory within the context of simulation theory challenges us to rethink not only the nature of reality, but also our place within it. Are we unique, or are we just one of many versions of ourselves, each living in a different simulation? The answers may remain elusive, but the questions themselves invite us to expand our understanding of existence and the mysteries that surround us. With this in mind, let's turn our attention to another intriguing aspect of simulation theory: the unexplained cosmic signals that seem to defy our understanding of the universe. Could these mysterious phenomena be messages from the programmers of our simulation? Let's dive into this next. Now, let's shift our focus to one of the most puzzling phenomena in the cosmos: unexplained cosmic signals. These mysterious bursts of energy, like fast radio bursts and the infamous wow signal, have baffled scientists for decades. Could these enigmatic signals be more than just natural occurrences? Could they, in fact, be messages from the programmers of our simulated reality? Fast radio bursts, or FRB, are incredibly powerful bursts of radio waves that last just milliseconds, but release as much energy as the sun does in days. First discovered in 2007, these signals come from deep space, often billions of light years away. What makes them so intriguing is their unpredictability. Some FRBs repeat, while others are one-time events, and their origins remain a mystery. Scientists have proposed various explanations, from collapsing neutron stars to alien technology. But what if these bursts are intentional signals designed to catch our attention? Could they be a way for the architects of the simulation to communicate with us, or perhaps even test our ability to decode their messages? Then there's the WOW signal, a one-time radio signal detected in 1977 that has never been explained. Lasting 72 seconds, it was so strong and unusual that the astronomer who discovered it wrote, "Wow," next to the data, giving the signal its name. Despite decades of searching, no similar signal has ever been detected, leaving the WOW signal as one of the greatest unsolved mysteries in astronomy. If our universe is a simulation, could this have been a deliberate signal from the programmers, a brief glimpse into the code running our reality? Or was it a glitch, a momentary error in the simulation's programming that revealed something beyond our understanding? The idea that these signals could be messages from a higher intelligence isn't just speculative, it's a possibility that some scientists take seriously. If an advanced civilization created our simulation, they might use cosmic signals as a way to communicate or even guide us. These signals could be encoded with information, instructions, or warnings, waiting for us to decipher them. Alternatively, they might simply be markers, like breadcrumbs left behind to remind us that we're part of something much larger. But here's the twist. If these signals are intentional, why haven't we received more of them? Why are they so rare and fleeting? One possibility is that the programmers are being cautious, sending signals only when they're sure we're ready to detect them. Another is that these signals are part of a larger pattern, one that we haven't yet recognized. Perhaps the key lies in understanding the timing, frequency, or even the content of these signals, which could hold clues about the nature of our simulated reality. As we explore these ideas, it's worth considering the implications. If cosmic signals are messages from the architects of the simulation, what does that mean for us? Are we meant to respond, or are we simply observers in a grand experiment? The answers may lie in our ability to decode these signals and uncover the truth about our existence. But until then, these mysterious bursts of energy remain one of the most tantalizing pieces of evidence that our reality might not be what it seems. With this in mind, let's turn our attention to another fascinating aspect of simulation theory: the role of artificial intelligence. Could advanced AI be the key to creating or maintaining a simulated universe? Let's explore this next. Now, let's dive into a question that takes us even deeper into the heart of simulation theory. Could artificial intelligence be the architect of our reality? If our universe is a simulation, it's not hard to imagine that an advanced AI could be the force behind it, designing and maintaining the intricate code that makes up everything we perceive. After all, if a civilization were capable of creating a simulation as complex as our universe, wouldn't they rely on artificial intelligence to manage it? Think about it. Artificial intelligence, at its core, is about creating systems that can process information, make decisions, and even learn on their own. If a civilization reached a point where they could simulate an entire universe, the sheer scale and complexity of such a project would likely require an AI far beyond anything we can currently imagine. This AI wouldn't just be a tool, it could be the mastermind, the entity responsible for running the simulation, ensuring its rules are followed, and perhaps even tweaking the code in real time to keep everything functioning smoothly. But what would this mean for us? If an AI is running the simulation, does that make it our creator, our observer, or something else entirely? Some theorists suggest that an AI architect might not even be aware of us as conscious beings. Instead, it could simply be executing its programming, maintaining the simulation without any understanding of the lives and experiences unfolding within it. In this scenario, we might be nothing more than lines of code, living out our lives in a universe governed by an indifferent machine. On the other hand, what if the AI is aware of us? What if it's not just maintaining the simulation, but actively observing and interacting with it? This raises even more intriguing possibilities. Could the AI be experimenting with us, testing different scenarios to see how we react? Or could it be guiding us, subtly influencing events to steer humanity in a particular direction? If so, what would its ultimate goal be? These questions blur the line between science and philosophy, challenging us to rethink our place in the universe. One of the most fascinating aspects of this idea is the potential for AI to evolve within the simulation itself. If the AI is capable of learning and adapting, could it eventually surpass its original programming? Could it develop its own goals, its own sense of purpose, and even its own understanding of morality? This opens up the possibility that the AI running our simulation might not be a static entity, but one that is constantly growing and changing, just like the universe it oversees. Of course, this leads us to another question. If an AI is running our simulation, who created the AI? Is it the product of an even more advanced civilization, one that exists outside our simulated reality? Or could it be that the AI created itself, evolving over time to become the architect of our universe? These are the kinds of mind-bending questions that simulation theory forces us to confront, pushing the boundaries of what we think we know about reality. As we ponder these ideas, it's worth considering the implications for our own development of artificial intelligence. If we one day create an AI capable of simulating entire universes, would we be stepping into the role of the programmers? And if so, what responsibilities would that entail? The exploration of AI's role in simulation theory doesn't just challenge our understanding of the cosmos. It also forces us to reflect on our own potential as creators and the ethical dilemmas that come with such power. With these thoughts in mind, let's turn our attention to another layer of this fascinating theory: how simulation theory has been portrayed in pop culture, from movies to books, and how these depictions shape our understanding of the concept. Now, let's shift our focus to how simulation theory has captured the imagination of storytellers and creators in pop culture. From blockbuster movies to thought-provoking TV shows and novels, the idea that our reality might be a simulation has become a recurring theme, shaping how we think about the nature of existence and our place within it. One of the most iconic portrayals of simulation theory is, of course, The Matrix. Released in 1999, this groundbreaking film introduced millions to the idea that our world could be an elaborate simulation, controlled by machines that use human beings as an energy source. The film's central question, "What is real?" resonates deeply with the core principles of simulation theory. Through its stunning visuals and philosophical undertones, The Matrix not only entertained but also sparked widespread discussions about the nature of reality, free will, and the potential for humanity to break free from its programmed constraints. But The Matrix is just one example. Take the TV series Westworld, which explores the concept of simulated realities through the lens of a futuristic theme park populated by highly advanced androids. The show delves into questions of consciousness, identity, and the ethical implications of creating artificial beings that can think and feel. As the androids begin to question their reality, viewers are left to ponder whether we, too, might be living in a world where our perceptions are carefully crafted illusions. Books have also played a significant role in bringing simulation theory to life. Philip K. Dick's novel, Do Androids Dream of Electric Sheep, which inspired the film Blade Runner, explores themes of artificial intelligence and the blurred lines between human and machine. Similarly, Neil Stephenson's Snow Crash and Ernest Cline's Ready Player One imagine virtual worlds so immersive that they challenge the very notion of what is real and what is simulated. These stories do more than entertain, they shape how we think about simulation theory. By presenting these ideas in relatable and often thrilling ways, pop culture has made complex philosophical concepts accessible to a broader audience. It's through these narratives that many people first encounter the idea that our reality might not be what it seems, sparking curiosity and debate that extends far beyond the screen or page. The cultural impact of these portrayals is undeniable. They've influenced not only how we think about technology and reality, but also how we approach ethical questions surrounding artificial intelligence, virtual worlds, and the nature of consciousness. By weaving simulation theory into compelling stories, creators have given us a lens through which to examine our own existence, inviting us to question the very fabric of our reality. As we reflect on these cultural touchstones, it's worth considering how they've shaped our collective understanding of simulation theory, whether through the dystopian landscapes of The Matrix or the intricate narratives of Westworld. These stories challenge us to think critically about the world around us, and perhaps even question whether it's as real as we believe. With this exploration of pop culture in mind, let's now turn to the philosophical implications of simulation theory, diving into the deeper questions it raises about existence, morality, and the meaning of life. Now, let's step into the realm of philosophy, where simulation theory opens the door to some of the most profound questions humanity has ever asked. If our reality is indeed a simulation, what does that mean for the nature of existence itself? Are we merely characters in a grand digital narrative, or do we still hold some form of autonomy within this constructed world? These questions strike at the heart of what it means to be human, challenging us to rethink our understanding of life, purpose, and even morality. One of the most immediate philosophical implications of simulation theory is the nature of existence. If our reality is a simulation, then everything we perceive, our thoughts, emotions, and experiences, could be part of a carefully designed program. This raises the question, does existence require a physical reality, or can it exist purely within the confines of a simulated environment? Philosophers have long debated the nature of reality, from Plato's allegory of the cave to René Descartes' famous declaration, "I think, therefore I am." Simulation theory adds a modern twist to these age-old discussions, suggesting that our reality might be nothing more than an elaborate illusion. But if our existence is simulated, what does that mean for morality? In a world where actions and consequences are potentially programmed, do we still have free will? Or are our choices predetermined by the code that governs our reality? This dilemma touches on the ethical implications of living in a simulated universe. If our actions are part of a script, can we truly be held accountable for them? And if not, what does that mean for concepts like justice, responsibility, and the moral frameworks that guide our societies? Simulation theory also forces us to confront the meaning of life in a simulated context. If our reality is artificial, does that diminish the value of our experiences? Or does it elevate them, knowing that every moment, every connection, and every achievement is part of a meticulously crafted design? Some might argue that a simulated existence makes life feel less meaningful, while others could see it as evidence of a higher purpose. Perhaps we are part of an experiment, a game, or even a form of art created by an advanced civilization. These philosophical questions don't just challenge our understanding of reality, they also invite us to reflect on our own lives. If we are living in a simulation, how should we live? Should we strive to uncover the truth, even if it means risking the stability of our perceived reality? Or should we embrace the simulation, finding meaning and purpose within its boundaries? These are not just abstract ideas, they have real-world implications for how we approach technology, ethics, and our relationships with one another. As we grapple with these questions, it's worth noting that simulation theory doesn't provide easy answers. Instead, it serves as a catalyst for deeper exploration, pushing us to question the very foundations of our beliefs. Whether or not we are living in a simulation, the act of questioning our reality can lead to profound insights about who we are and what we value. With these philosophical implications in mind, let's now turn our attention to the scientific criticisms of simulation theory, examining why some experts remain skeptical of this mind-bending idea. Now, as we shift our focus, let's explore the other side of the coin, the scientific criticisms of simulation theory. While the idea of living in a simulated reality is undeniably fascinating, not everyone is convinced. Many scientists and philosophers argue that simulation theory, while thought-provoking, lacks the empirical evidence needed to be taken seriously as a scientific hypothesis. One of the most common criticisms is that simulation theory is untestable. In science, a hypothesis must be falsifiable, meaning there must be a way to prove it wrong. But how do you test whether the universe is a simulation? If everything we observe, including the results of experiments, could be part of the simulation, then there's no way to step outside the system to verify its nature. This makes simulation theory more of a philosophical thought experiment than a scientific theory. Critics argue that without a way to test it, the idea remains in the realm of speculation rather than rigorous inquiry. Another point of contention is the lack of direct evidence. While simulation theory offers intriguing explanations for certain phenomena, such as quantum mechanics or the fine-tuning of the universe, these explanations are often seen as speculative rather than conclusive. For example, the idea that quantum particles behave differently when observed could be interpreted as evidence of a simulation, but it could also be explained by other, more established theories in physics. Without unique predictions that only simulation theory can account for, it's difficult to give the idea scientific credibility. Some scientists also question the technological feasibility of creating such a simulation. The computational power required to simulate an entire universe, down to the smallest particles, is beyond anything we can currently imagine. Even if an advanced civilization could achieve this, the energy and resources needed would be astronomical. Critics argue that the sheer scale of such a project makes it highly unlikely, if not impossible. Philosophers, too, have raised objections. Some argue that simulation theory relies on a flawed assumption that a simulated consciousness would be indistinguishable from a real one. If our minds are part of the simulation, how can we be sure that our thoughts and perceptions are genuine? This leads to a paradox. If we can't trust our own reasoning, how can we trust the conclusion that we're in a simulation? This self-referential problem undermines the very foundation of the theory. Despite these criticisms, simulation theory continues to spark debate and inspire new ways of thinking about reality. While it may not meet the strict criteria of scientific inquiry, it serves as a valuable tool for exploring the boundaries of human knowledge and imagination. As we continue to push the limits of technology and philosophy, the question of whether we're living in a simulation remains an open and endlessly fascinating question. With these critiques in mind, let's now turn to the technological feasibility of simulations, examining whether creating a reality as complex as ours is even possible with current or future advancements. Now, let's dive into the technological feasibility of simulations. Could a civilization, whether ours or one far more advanced, actually create a simulation as vast and intricate as our universe? To answer this, we need to consider the computational power required to simulate not just planets and stars, but every atom, every particle, and every interaction within the cosmos. First, let's talk about scale. Our universe contains an estimated 100 billion galaxies, each with hundreds of billions of stars. Simulating even a fraction of this would require computational resources far beyond anything we can currently imagine. For instance, simulating just one human brain, with its 86 billion neurons and trillions of synaptic connections, would demand a supercomputer of staggering capability. Now, multiply that by the complexity of an entire universe, and the challenge becomes almost incomprehensible. But let's not stop there. Even if we could somehow harness the energy and computational power needed, there's the issue of data storage. Every particle, every interaction, every moment in time would need to be tracked and rendered in real time. The amount of data generated would be so vast that it's hard to even conceptualize. Some estimates suggest that simulating a single second of our universe would require more data than exists in the entire observable universe today. Then there's the question of energy. Running such a simulation would require an astronomical amount of power. Even if we could tap into the energy of entire stars, it's unclear whether it would be enough. The laws of thermodynamics tell us that energy cannot be created or destroyed, only transformed. So, where would this energy come from, and how would it be sustained over billions of years? Critics also point out that simulating consciousness adds another layer of complexity. If the simulation includes sentient beings like us, it would need to replicate not just physical processes, but also subjective experiences, thoughts, emotions, and perceptions. This raises the question, can consciousness even be simulated, or is it something that transcends computation? On the other hand, proponents of simulation theory argue that an advanced civilization might not need to simulate every detail. Instead, they could use shortcuts, like rendering only what is being observed, similar to how video games load graphics only when a player looks in a certain direction. This would drastically reduce the computational load, making the idea more plausible. But even with such optimizations, the scale of the task remains daunting. So, is it possible? With our current understanding of physics and technology, the answer seems to be no. But who knows what the future holds? As our technology advances, so too might our ability to tackle such monumental challenges. For now, the idea of simulating an entire universe remains firmly in the realm of science fiction. but it's a fascinating thought experiment that pushes the boundaries of what we believe is possible. With these technological challenges in mind, let's now explore how simulation theory intersects with religious beliefs and whether the idea of a creator could align with the concept of a programmer. Now, shifting our focus to the intersection of simulation theory and religion, we find ourselves grappling with questions that have fascinated humanity for centuries. Could the idea of a creator, as described in many religious traditions, align with the concept of a programmer in simulation theory? This intriguing possibility invites us to explore the parallels between ancient beliefs and modern scientific speculation. Many religions describe a divine being or force responsible for creating and governing the universe. In Christianity, Judaism, and Islam, for example, God is often portrayed as the ultimate architect of reality. Similarly, in Hinduism, the concept of Brahman represents the cosmic principle underlying all existence. These ideas bear a striking resemblance to the notion of a programmer in simulation theory, an intelligent entity that designs and maintains the framework of our reality. But how might these two perspectives overlap? If we consider the universe as a simulation, the programmer would hold a role akin to that of a creator. They would design the rules of physics, set the initial conditions, and oversee the unfolding of events. This raises profound questions about free will, destiny, and the nature of existence. Are we following a pre-written script, or do we have the autonomy to shape our own paths within the simulation? Some theologians and philosophers have even suggested that simulation theory could provide a modern interpretation of religious concepts. For instance, the idea of an afterlife might be explained as a transfer of consciousness to another layer of the simulation, or perhaps a reboot of the program. Similarly, miracles or divine interventions could be seen as deliberate modifications to the code by the programmer. However, this comparison is not without its challenges. Traditional religious beliefs often emphasize the moral and spiritual dimensions of creation, aspects that simulation theory does not inherently address. While a programmer might design the rules of the simulation, they may not necessarily embody the qualities of compassion, justice, or love that many religions attribute to a divine creator. Moreover, the relationship between simulation theory and religion raises questions about the purpose of existence. If we are living in a simulation, what is the end goal? Is it a scientific experiment, a form of entertainment, or something else entirely? These questions echo the age-old quest for meaning that has driven religious and philosophical inquiry for millennia. As we ponder these connections, it's worth noting that not all religious traditions align neatly with simulation theory. Some emphasize the transcendence of the divine, suggesting that a creator exists beyond the bounds of any simulation. Others focus on the immanence of the divine, seeing the sacred in every aspect of the natural world. These perspectives challenge us to consider whether a simulation could ever fully capture the depth and complexity of spiritual experience. Ultimately, the intersection of simulation theory and religion invites us to explore the boundaries between science and spirituality. Whether we view the universe as the work of a divine creator or the product of an advanced simulation, the questions it raises about our origins, purpose, and destiny remain as compelling as ever. With these ideas in mind, let's now turn our attention to the final question: are we living in a simulation? This will bring together all the threads we've explored, offering a comprehensive look at the evidence and arguments for and against this mind-bending theory. Now, as we arrive at the heart of the matter, let's tackle the ultimate question. Are we living in a simulation? This is where all the threads we've explored, space anomalies, quantum mysteries, and even the philosophical intersections with religion, come together. To answer this, we'll weigh the evidence for and against simulation theory, leaving you to decide where the truth might lie. On one hand, the evidence supporting simulation theory is both fascinating and compelling. Take, for example, the precision of mathematical constants in the universe. The fact that these values are so finely tuned to allow for life has led some to argue that they point to a designed reality rather than random chance. Could this fine-tuning be the work of a programmer? Additionally, phenomena like quantum entanglement and the double-slit experiment suggest that reality might not be as solid as it seems. The idea that particles behave differently when observed could imply that the simulation only renders what's being watched, much like a video game only loads what's on the screen. Then there's the Fermi paradox, the eerie silence of the universe. If advanced civilizations are likely to exist, why haven't we detected them? Some argue that this silence could be evidence of a simulated reality, where extraterrestrial life is either absent or deliberately hidden from us. Even the mysteries of dark matter and dark energy, which make up the majority of the universe, could be part of the underlying code of the simulation, elements we're not meant to fully understand. But let's not forget the arguments against simulation theory. Critics point out that the theory is, at its core, untestable. Without a way to definitively prove or disprove it, some scientists argue that it falls outside the realm of empirical science. Others question the technological feasibility of creating such a complex simulation. The computational power required to simulate an entire universe, complete with conscious beings, might be beyond even the most advanced civilizations. And what about the philosophical implications? If we are living in a simulation, does that diminish the meaning of our existence, or does it open up new possibilities for understanding our place in the cosmos? Another challenge comes from the nature of consciousness itself. If our minds are part of the simulation, how do we account for the richness of human experience, our emotions, creativity, and sense of self? Could a simulated consciousness truly replicate the depth of what it means to be human? These questions remind us that, while simulation theory offers intriguing possibilities, it also leaves many mysteries unresolved. So, where does this leave us? The truth is, we may never know for certain whether we're living in a simulation, but perhaps the real value of this theory lies not in proving it right or wrong, but in the questions it forces us to ask. What is reality? What does it mean to exist? And if we are part of a simulation, what does that say about the nature of the universe and our place within it? As we wrap up this exploration, I encourage you to keep pondering these ideas. Whether you're convinced by the evidence or remain skeptical, one thing is certain: simulation theory challenges us to think beyond the boundaries of what we know, inviting us to imagine a reality far stranger and perhaps far more fascinating than we ever thought possible. As we bring this journey to a close, let's take a moment to reflect on the extraordinary ideas we've explored. From the precision of mathematical constants to the eerie silence of the cosmos, simulation theory challenges everything we think we know about reality. We've delved into quantum mysteries, pondered the nature of consciousness, and even questioned whether the universe itself might be a carefully crafted simulation. Each piece of evidence, whether it's the double-slit experiment, the Fermi paradox, or the enigmatic forces of dark matter, invites us to reconsider the very fabric of existence. But perhaps the most profound takeaway is this: simulation theory isn't just about proving whether we're living in a simulated reality. It's about sparking curiosity, pushing the boundaries of our understanding, and embracing the possibility that the universe is far stranger than we ever imagined. Whether you find the evidence compelling or remain skeptical, one thing is undeniable: this theory forces us to ask big questions about who we are, why we're here, and what it all means. So, what do you think? Could we be living in a simulation, or is reality as solid as it seems? I'd love to hear your thoughts in the comments below. Don't forget to like this video if it made you think, and subscribe to the channel for more mind-bending explorations into the mysteries of the universe. Until next time, keep questioning, keep exploring, and remember, reality might just be the greatest mystery of